Hello everyone, moyin.dev here. Today we have our free class, which is an introduction to artificial intelligence and data science, demystifying certain concepts you might have heard, taking a closer look at it just to break it down and then make it more easier to understand, more easy to assimilate and relate with. So first, an introduction to the brand moyin.dev. Moyin.dev is a brand that came to be this year. It's always an idea I've always followed with. An idea is considered a lot, but the idea came to fruition later this year, currently. So moyin.dev is a brand that is devoted to just one main thing: to build individuals or developers who go ahead to build digital products that create impact within the community. So all we're about is actually to create impact. So we want to teach and then set persons who are being taught, then go ahead to build these products. So the big picture here is not just to teach things like AI and data science, but to bring in other aspects such as UI, UX, web development, and so much more. So we want to equip learners with hands-on tech skills that are immediately applicable in the real world. So we are heavy and big on problem solving. That's moyin.dev. Then foster a creation of real-world AI data products from conception to completion, a community of innovative developers, problem solvers, and tech enthusiasts. So like I said, we are big on problem solving, we are big on making impact. So let's get into the class, starting from data science. What is data science? Data science is simply the science of extracting meaningful insights from data. That's all. So data from our computer science, as we all know, is the raw form in which certain observations exist. So the raw form in which observations are collected, that is data. So forms of data you could have could be audio, could be video, whatever it is you want to call it. So data is collected and observed, then studied for information, and then extracted for meaningful insights. So that's just that whole pipeline is data science, extracting meaningful insights from data. And when people hear about data science, it seems so cumbersome, so foreign and out of this world. And believe me, I tell you, data science is something you do every single day without even thinking of it. A common example I like to give is something like NEPA now. We all know that we have an erratic power supply in Nigeria here. Something that is very, very common is you get to a new space, a new environment. After about 3 days, after a week, after a month, you start to notice pattern in how the light comes. So you could say, oh, there's a pattern. Light comes between 6 a.m. to 2 p.m. Around 2 p.m., they'll take it and bring it back by 8 p.m. at night. Do you get? So you start to notice patterns in the data. What you didn't know is behind the scenes, your brain has collected a month's worth of data. Just noticing when NEPA brings lights, when NEPA takes lights, just data. Your brain has not analyzed this to figure out that, wait, today they brought it in the afternoon. It was the same yesterday. This must mean that there's a pattern here. With that pattern, your brain has extracted insights from that data and then gone ahead to make a theory out of it. So that's just what data science is about. You take observations, you analyze them, you create meaningful insights. Those insights can now be used to build a model that makes predictions based on the insights. So data science is nothing abstract, nothing hard. It's something we do every single day. It's something that can be applied to every single sphere of life you can think of, every single one. So just to mention certain things that are composed in data science, we have statistics, mathematical foundation of understanding data trends. We have programming, use programming languages like Python to build this out. Machine learning, these are algorithms that enable your computer to learn. Then domain knowledge, expertise in a specific field. Like I said, you have to apply data science to a specific field. So the goal is to use data to make better decisions, predictions, transforming raw information into strategic advantages. And believe me, a good data science pathway separates big companies from other big companies. It gives an edge that certain companies, if you don't have that edge, you wouldn't know how much it costs. Because I tell you, I'll give an example later on. It's an example about the restaurant. I'll give you later on in the class. So talking about data science now, And data science is an umbrella term under which AI and then machine learning then exist. So yeah, so we have data science on top, then we have artificial intelligence, after which machine learning then comes under. So artificial intelligence now, this is a broad concept that refers to creating machines that think and reason and learn like humans. So a common quote I like to say is a quote from a mentor of mine: artificial intelligence is born from human intelligence. That's just what you need to know about artificial intelligence. Artificial intelligence tries to mimic how humans learn, how humans are intelligent. So the concepts you see in AI will be something like neural networks. Neural networks is just trying to mimic the network of neurons in one's brain. That's just what artificial intelligence is. A way by which we mimic human intelligence for the machine to learn. That's it. Then machine learning is a subset, so a method under artificial intelligence. So one of the methods by which we achieve artificial intelligence is machine learning, which is an algorithm that allows computers to learn from data without being explicitly programmed. So in programming, right, what we learned about computers from our primary school is computers are garbage in, garbage out. Is what you give it like to do. So if you want the computer to do something, you have to specify every single step of the way. Do it. So you want to tell the computer now, open this door, you have to specify every step. That's why you see flowcharts and then decision logics that we learned in computer science back then, where you see things like, stand up, walk 5 steps, do this, do that. Every single thing has to be explicitly stated. In programming, traditional programming. In machine learning, you don't have to state it, right? You just create an algorithm for the machine to learn. So the machine learns the pathways itself. You are not explicitly coding those pathways. So a machine can learn to open a door by you just creating an algorithm that allows it to learn how to open a door. So we'll go into this later on. So key idea, right? AI is the ultimate goal. Machine learning is a powerful method to achieve that goal. So why exactly does AI and data science matter? It is a global technology driver. I don't know if you are very familiar with big tech companies like Apple, Samsung, Google that create phones. If you watch any of their phone unveilings, one thing every company was heavy on this year was AI. Because artificial intelligence is that guy. Artificial intelligence is that trend, and believe me, it is here to stay. So one thing I said in previous times is in the discussion we had on our group is you have to learn to apply AI to anything you are doing. Don't see artificial intelligence as a threat. See it as a companion. It is a tool. It cannot just take your job unless you allow it, right? You have to evolve. So artificial intelligence is a tool to do some tedious part of your job. If all you do is that tedious part, then you have to evolve such that you allow the artificial intelligence to take over the tedious part. You focus on the creative aspects, and then you evolve. You make yourself, you use AI to give yourself an edge. For me, that's why I say artificial intelligence is not a threat. It's a companion. You just have to know how to use it. You have to know how to apply it. So AI is a global technology driver. It is something every single big tech company is focusing on now. You see Microsoft Copilot in meetings, just analyzing meetings and the like. So it's a global technology driver. Inform business decisions. You can use data science to make informed business decisions. You can use data science to analyze, why am I having low sales at this particular period of the year? Because of that, you can make informed decisions to know that, okay, it's because of a certain employee or something, or it's because of a certain trend that I'm having low sales. So I'm going to get into an example later on. Then solving real life problems. You can use data science to solve real life problems. I think let me just give you the example here. An example could be, let's say I have a restaurant now, right? I noticed that, you know what, every single time, I noticed that over the years, right, every Thursday around 5 p.m., I have low sales. From 5 p.m. to 9 p.m., I have low sales. And it seems weird. Why is it that every Thursday between 9 p.m. and 5 to 9, I'm having low sales? I am a data scientist. Look at the data. Look at the observations. What's going on? Help me understand it. And the data scientist comes, analyzes a lot of things like who was on duty during 5 to 9 p.m. every single time. What was happening during 5 to 9 p.m. every single time. What you could notice is, let's say I sell potatoes, right, in my restaurant. And then with data science analysis such that, you know what, by the hours between the hours of 5 to 9, another potato vendor opens opposite me or opens around me, and people prefer this person's potato to mine. And then I'm like, oh, that is why I've been having low sales. Do you get? So this is just to give you a gist of what data science do. Data science takes into account a lot of data, as much as possible you can gather. If you get, it could even take into the wind speed. Is there AC? Maybe between the hours of 5 to 9 p.m. there is always heat stroke, and because of the heat, people don't like coming, so they don't like buying things. So it takes into account all of this just to analyze and give you an answer to what's happening. And with that answer, you can make informed business decision. An informed business decision could be, oh, let's say between the hours of 5 to 9 p.m. there's a climate condition causing heat stroke. People are not coming to my restaurant. I know that between 5 to 9, I have to increase the amount of ACs I'm using. I have to make sure I have solar power in my ACs. Because of that, boom, problem solved. So that's just how you make informed business decisions. That's how you solve real life problems with data science. Another real life problem you could solve is related to healthcare. There's just many applications. Can't go into everything. So AI is a rapidly growing career path, believe me. If you enter into AI now, it's something that will rapidly evolve over time. Even the AI would think, oh, it's good today, tomorrow it's not the best again. AI is rapidly evolving because of the amount of data it's churning out. Back then, the best we had was like maybe GPT 3.5. Now they're saying GPT 5s. This is just telling you that AI is constantly evolving, it's constantly getting better, and this is future proof, believe me. So let's just go into the types of machine learning quickly. So we have three main types here, three major types that you have to consider. Remember what we said about machine learning? Remember what we said about machine learning? Machine learning, it's simply an algorithm for the machine to learn such that it mimics artificial intelligence. So the way we learn as humans, the machine mimics that using machine learning. That's all. So machine learning is a method, an algorithm for the computer to learn how to do something. So what are the differences? You have supervised learning. Supervised learning is basically, let me use an example from human intelligence here. Let's say I want to teach a 5-year-old how to identify a girl from a boy, right? Just using their external characteristics, not checking out their sexual parts. So an arbitrary example that I'll just give is females wear braids, men wear low cuts as their hairstyles. So let's just focus on hairstyles now. So I tell the newborn, right? So I'm making an assumption here. Every female is on braids, every male is on low cuts. I tell the child, the 5-year-old child, look, I want you to classify male and female. This is how a male looks like. Every male you see will be on low cuts. Okay? The 5-year-old understands that. Okay, this is a low cut. Every male will be on a low cut. This is a braid. The hair is longer. Every female will be on braid. Do we get? So now, after telling the child how to identify male and females, if I bring someone new, the child will be like, okay, is this person on braid or on low cut? I know braid, I know low cut, and be able to identify and distinguish which is which, and then classify male to female. That's exactly what supervised learning is for artificial intelligence. You pass in a set of images, right, of males, and you say, look, this box, right, is males that are inside. These are pictures of males. So what the artificial intelligence will now do is find similarities between those pictures. And from the assumption we made that everyone is on low cuts, the AI will find a similarity that, every single person here is on low cuts, and the label here says male, which means every single person on low cuts is a male by the labeling. That means the AI was told the answer. The AI was given the label. Then it goes to the same thing for females too. You have pictures of people on braids, you label it female. AI sees the pattern, braids, says these are females. So because of that, you supervised the learning. You've been actively involved in the learning. You taught the AI what you want, what a male looks like, what a female looks like. And then you can now bring a new picture, a new image that the AI has not seen before, and tell it, is this a male or a female? It will be like, I'm expecting similar patterns. Is the similar pattern I'm saying here, is it similar to male or is it similar to female? Basically, is the person on low cut or is the person on braids? And by that, you can classify and say, oh, this is a male, this is a female. That's supervised learning, right? Basically, learns from labeled input, but both the inputs and desired outputs are known. So the input is the image, desired output is whether it's male or female. Then commonly used for classification like spam detection, regression, predicting house prices, which is something we'll be doing later on in this class. So unsupervised learning is where it gets freestyle. So we use this usually when we don't have enough data to do supervised learning. So when we lack the data to do supervised learning, we are like, you know what, can I build an algorithm where without me telling the artificial intelligence, without me telling the AI to write how a female looks like, how a female looks like, I'll just give it a bunch of pictures and then it will be able to identify a cluster such that this is a cluster of similarity, this is a cluster of similarity. So you just be like, oh, this cluster of images, all of them are on lookup, which means this is a group. This cluster of images, all of them are on braids, which means this is another group. So you are basically creating an algorithm where you did not specify which is which, but the AI learns the patterns, analyzes that there are similar patterns and similar images, and groups those images together. Similar patterns on a different set of images, groups those images together. Then I'll be like, okay, this is A, this is B. Now, because of that, you can now pass it a new image and to say, okay, I've seen this before. They look very, very similar to A. That means this picture must be A. So that's just what unsupervised learning is. It discovers hidden patterns and structures within data that do not have pre-existing labels. It is primarily used for structuring and association. Now, we have reinforcement learning. Reinforcement learning is basically you are teaching the computer to learn by rewarding good actions. So how that works is, think of a game now, right? Let's say we are playing a chess game or we are playing a puzzle, Subway Surfers or something. I think I'll use Subway Surfers because that's relatively common. Or, you know what, let's use chess. Chess is more common. So you play a move in chess, right? Depending on how good the move is, you give a point to the AI. So let's say in pawns move straight, right? Let's say the AI makes a move where the pawn walks into a trap. You give a negative. The AI learns, oh, that's a bad move. It tries another move. Okay, with this move, oh, my bishop escapes. You give a plus. So the AI learns, oh, this is a bad move, this is a good move. So with that, the AI sort of learns the patterns around good moves, such that it continues and continues and continues to make a good move. So that's what basic reinforcement learning is. Reinforcement learning is, it mimics what you see in babies when they try to learn. So you could see a baby now trying to walk, right? What they'll try to do is, oh, they try to stand on 1 foot. Maybe they try to stand first. It's wobbly. They fall. They say, oh, what happened? Why was that wobbly? Oh, maybe because I didn't engage my core very well. Then they try to engage their core. They see that it's better. So that's a reward, right? But still they fall. They're like, okay, let me try again. What's happening? Then they're like, oh, when I rest a bit on my left feet, it's better. That's a reward, right? But still they fall. Then they stand up and they try again. Oh, it's because I rested too much on my left feet. That's why I fell. So each fall is a negative, right? So each good point will make them stay. We make them stay upright. Each fall is a negative. Do we get? So every time they get a plus, they try to replicate what they did to get a plus. But then they learn that, oh, there's a limit to what I'm replicating. So then they switch to another thing and then they get a plus. So it could be like, oh, you are resting so much on your left leg. That's why you fell. That's why you got a negative. You try again, you get to that plus, and you're like, okay, let me change this. Let me rest on my right leg. And then you see, oh, for me to walk, that means I have to rest on my left and my right leg. Plus and a plus. So that's just how reinforcement learning is. You reward good actions. You punish bad actions. That's all. So an agent learns to make decisions by interacting with an environment, receiving rewards for desired actions, and penalties for undesired ones. This is widely applied in areas like robotics and advanced games, autonomous systems. So, example of machine learning in real life, we see spam detection Of course, we know that from our messages, from our mails, we see product recommendations where the AI sort of learns that, oh, you viewed this particular product, you stayed on this page for maybe about a minute or 2 minutes. That must mean you really like this product. You know what? I'll recommend something like that, something similar to it. That's what product recommendation, that's how it works. Same thing with video recommendations, although different apps have how they implement it. Somewhere like TikTok now, one way to implement could be something like, oh, the longer you stay on this video, the more you must like this video. That means I should bring another video like it. And believe me, these companies like TikTok, like YouTube Shorts, they get paid good money just to develop algorithms that are able to recommend videos better. So very, very beautiful algorithms. I've seen some good ones. You have YouTube Shorts too. YouTube could implement it in a different way. You have Instagram Reels too that does that. So these are just real life scenarios by which we apply machine learning. Another is fraud detection. Let's say I have a pattern where I'm always sending 2K every day. I'm only sending 2K every day, 2,000. All of a sudden, I'm sending 200,000. I'm sending 500,000. And this was after I sort of made, let's say I enter my bank app. Normally, I would have entered my bank app and then paid straight up. But this time around, I entered my bank app, I quit. I entered my bank app, I quit. I entered my bank app again, and then boom, I'm making a purchase of 500,000. The AI sees that there's a different pattern happening. So it's like, what's going on? This must look like it's not in. So it then flags it for fraud detection, and then for you to make that particular purchase, you might have to take an extra measure, like maybe a facial recognition or something to prove that it's really you. That's how fraud detection works. Then voice assistants, these are just basically your ChatGPT assistants, the voice model. Then you have self-driving cars, beautiful thing that Tesla is doing, where Elon Musk is working on. Medical diagnosis too, worked on this, where you can teach a machine how to identify X-rays with patches. So that could be used as a way to diagnose a condition like pneumonia. So you can just scan the X-rays and be like, oh, you know what? Detecting those patches there in with better accuracy than what you do with the ordinary naked eye, because it breaks it down into pixels. So believe me, the gist about vision, computer vision, it's something we'll get into in a different class. Very, very beautiful concept, a very beautiful way to actually achieve this. So it's very interesting to talk on, but this is not the class to talk about that. Then house price predictions, which is something we are going to be working on today. So yeah. Data science workflow. Now we are getting into the thick of it. So, the data science workflow is simple. Remember what I said from the data. Remember what I said earlier, how we already apply data science to our everyday life. So, every data science work starts with a problem. So, let's take a case study here. For example, you know what? The problem is, I want to work at a day. Let's say I have an exam in a month, right? However, I don't know when lights will come, and I have to use lights for this exam. So my problem is I need lights a month from now for an exam, right? And let's say I need to use lights in my house, something like that. So the problem is me wanting to have lights at a specific time, me wanting to know when lights will come for an exam. Are we following here? So just stay with me. It makes sense. So first, the data we'll collect is data patterns on how light has been coming in previous times. So when has light been coming? When have they been taking lights? When has light been coming? When have they been taking lights? Why are we collecting this? Because we want to say with certainty that because of this pattern, if these assumptions hold true, lights will come on a specific time by this day. So you can set your exam time at this time on that day, because it's sure that lights will be around at that day. Do you get? So the problem is basically you want to fix a time for an exam a month from now, and you want to fix that time for an exam on a time that lights will be around. It wants there to be light. So you want to basically analyze patterns of when NEPA brings light, when NEPA takes light, when NEPA brings light, when NEPA takes light. So you collect this for about, let's say, a month. That's data collection. A month. Or you know what? Let's make the model better, because the more the data, the more better. It says let's collect data for as far back as 6 months. That's data collection, right? So we collect things like when they bring light, when they take it every day. When they bring light, when they take it every day. Let's just throw in a random value, the temperature of the house anytime they bring light, right? That will make sense later on. So we've collected our data, 6 months worth of data, telling us when they bring light each day and when they take it, when they bring light and when they take it, the amount of hours it spent, the voltage that it was it high, was it low? These are different data you can collect, right? Depending on what you want to do. And now, in our data cleaning, what we basically do is this. We want to check irrelevant values like temperature now, for example. That might not really matter to our to making that accurate prediction in the end, right? It might not really matter to telling us when they'll bring light. Temperature might not matter. So I say minds now, because who knows? You might later find out that it actually matters. That's the beautiful thing about data science. You might think something doesn't matter, but you just see that, wait though, after you analyze, it actually counted. So data cleaning is basically removing irrelevant values, things like null values. Let's say, for example, now, if you are supposed to give me the time lights stayed for like maybe 8 hours, and then you are giving me something like name, like a name, just random Akinshikpe or something, and it's like, I don't get, this is a wrong value for this field. So what data cleaning does is it tries to remove inconsistencies, like where you're expecting a number, you get a name, you get a word. It tries to remove that, tries to correct things. Any place where there is a null value is something like nil. So it's not zero, it's nil, right? You want to remove that too. Because in this case, 0 is a perfectly good number for the amount of hours light spent or something like that. But you don't have 0, you have nil. You want to remove stuff like that. You want to clean the data to make sure inconsistencies are not there. So for me, data science, data cleaning, and exploratory data analysis, they come hand in hand. And what do I mean by they come hand in hand? Data cleaning is basically, you analyze the data, you see the inconsistencies, right? Then you remove those inconsistencies. That's why they work hand in hand for me. So exploratory data analysis, EDA, will analyze those data. EDA is basically you plotting out the data graphically. Say yes. So it's like a pictorial format of the data. So it's like you are plotting out a graph of how many hours there was light each day, right? You plot out a graph of that, and it shows you the trend over the years, and it's like, oh, this is good, this is good. So EDA is the first step to drawing out insights from your data. EDA is the first step to discovering things about your data. EDA is the first step to actually telling you this matters and this matters about your data. So with exploratory data analysis, you learn a lot about your data, and by those things you've learned, you can identify the inconsistencies better and remove them with data cleaning. So that's why 3 and 4 are hand in hand for me. Next is feature engineering. Feature engineering is where you want to select the features that matter. What do I mean by features? I mean selected data points that matter. So an example is this, right? For our model, where you want to build a model that can predict when lights will come, so I can know when to fix my day, my time of exam on this particular day, do we get, or even the day of the exam. So feature engineering could be features such as the amount of hours light is coming per day. Do we get? That's a feature. When the light came, the time the light came every day, the time the light went every day. So those are like features that I can put. So let's say you keep saying, let's just use 24-hour format now. At 800 hours, right? That's 8 o'clock, 8 a.m. in the morning, the light came. Then as 1400 hours, that's 2 o'clock in the afternoon, the light went. It stayed for, so it takes for like 6 hours, right? I hope that's correct. I'm bad at math. So basically it spent 8 a.m. to 2 p.m. and then it stayed for XYZ amount of hours. So those are 3 data points: the time, the light came, the time the light went, the number of hours it spent. Those are 3 data points. Those are 3 features. Those are 3 columns. It's actually data points. Data point is not the word to call it, but I'm trying to make people understand it. A data point will be a single day. The data for a single day, a single cell, right? For those of us that know, that's what a single data point is, right? But a column is like a group of data, right? Trying to find the best way to explain it. But do you understand? Features are like the columns on an Excel table. So a column, for example, would be the number of hours the light spent. That's a column. That's a feature. So those are the things you sort of take into account to engineer a model. So feature engineering is basically selecting the features that matter to train the model, the features that matter to actually solving the problem. So you don't put a feature like temperature, it does not matter. Do you get? Then model breeding is where you fit the model. So to fit a model is basically to train the model. You want to fit the model to a line. So a line of best fit of sorts. I want to fit the line of best fit. That's basically why it's called fit, because it takes sometimes some statistics. So you are fitting the model, you are training the model, then you evaluate the model after you've trained it. You test it on new data it hasn't seen before. Then you deploy and you monitor for updates and the likes. So that is the data science workflow. And every single data science problem you are solving follows all of this. Trust me. So this is one of my favorite parts because it's something I can just keep replicating to solve any data science problem I have. It's something I can replicate to fix any problem I have. It's something I can replicate to do whatever it is I wish. So that is that's the vibe, that's the gist about the data science workflow. So you can just commit this to memory. At the point if you don't have to commit it because it just feels like part and parcel of you, because you've done it a lot of times. But yeah, you can just keep this to memory, take a screenshot of it. It's what we'll be working on, a lot going on. So this is also what I'll be following through to build the model, to work on the model we are looking through. So the model is built already, but we'll just be following these steps to just review it together. So yeah, what are the tools you need in data science? You have programming, Python, R. These are programming languages. Python is like the bread and butter for data science. You have libraries now. So let me just quickly explain this here because it's going to be a big part of what we do in the coming ones, in the review we'll be making. So a library now is, think of it this way. I have a set of functions I want to do. So let's say in terms of graphs now, right? I have a set of functions involved in plotting a graph. Something like draw a line, right? Something like plot these points. Something like join these points together. Do you understand? So there are a set of functions, a set of actions you take when you are plotting a graph, right? An action could be draw the X, that's the horizontal line, draw the vertical line, right? So sorry, is that correct? Yeah, draw the Y, which is the vertical line, draw the X, which is the horizontal line, then plot these data points. Those are 3 different actions. Then you're like, draw a line through these data points. I'm just trying to explain here. So all those actions, each of them is a function. So you have a function to draw an horizontal line, a function to draw a vertical line, a function to draw data points, etc. Now, you don't group all these functions together under a single library. That's what a library is. Do you get? So a library is basically a tool. For you to employ that tool can perform different actions. So all those different actions are the things you'll be using. But the library itself is think of it as a dictionary that contains a lot of tools that you can use. So you can just go and look at the dictionary that, oh, I want to use this tool. I want to use this action of this tool. Do you get? So that's just it. So it's kind of like when you buy a blender and you are reading the manual to see the amount of things the blender can do. Do we get? So because you buy a blender now, that's your library. That's different actions. You could have the dry blending and the wet blending. Those are 2 different actions. Those are 2 different methods, right? Let me just get technical now. Those are 2 different functions. You get? So functions, methods here, I'll use them interchangeably, but they are different. There's a slight difference between them though. For the sake of this, just know that functions, methods, actions, I'm saying they're the same thing. So all these functions that are similar to do one thing, they are now grouped together in a library. So a library is a tool has different actions. That's just the best way to make it. So pandas is a library for data manipulation. So pandas is like a library where you can take in your Excel sheets, CSV file. Your Excel sheet is one that has tables and rows, right? So pandas can take it in and then manipulate it. Manipulate it is like you want to delete a row, you want to add a row, you want to delete a number, you want to add a number, you want to do different things, you want to change things about your table. You can use pandas to do that. So pandas is a tool that has multiple actions that can act on the table. That's what pandas is for. So the other library here is NumPy. NumPy is basically American Python. So it has a number of functions, a number of actions by which you can manipulate numbers. You can work with numbers. So things like square root, things like standard deviation. These are all actions. These are all different methods for a tool for you to work with numbers. So that's what NumPy is. Those are libraries. So do you get the gist about how libraries are basically actions, a set of actions that are grouped together? That's what libraries are. So we have Matplotlib and Seaborn, which are libraries for you to do data visualization, which is basically plotting graphs. So as a library now, Matplotlib as a library has different actions for you to plot different graphs. Plotting pie charts is an action. Plotting pie charts is an action. From this point, I want to use function more. So just know an action is a function. So from this point, it has different tools like plotting that's different functions like plotting a graph, plotting a scatter plot, plotting a pie chart, and so much more. Then for the databases, you have different kind of databases you can use. You have the SQL databases and the NoSQL databases. We'll get into these technical times in the class. We have the cloud, which is AWS, Azure, so much more. Version control, Git and GitHub, which is basically a way for us to like collaborate, work on the same projects without causing confusion from one another. That's what Git and GitHub is. Then other tools like Power BI, Excel, like I mentioned, for advanced vision intelligence, and then interactive data visualization. So now we'll be going into our full and live demonstration of the Ibadan housing price prediction model. So yeah, this is a demonstration of basically a tangible example of how we created an AI to tackle a real world problem, a problem that still existed today, a problem that I'm facing currently. So it's just one of the beautiful things about being a developer. You could just face a problem and you could tell yourself, I could actually build a solution to this. Then you can go ahead and build a solution to that. Beautifully enough, you can then monetize the solution you build. So this is just trying to teach people about design thinking, how to think well, think big, think problem solving, think create impact. So yeah, see you in the next one. So yeah, good everyone, welcome back. So now we'll be taking a look at our we're taking a live review of the model we should create. So what I want to do is just walk you through the notebook. That's how we build the model, walk through the data science workflow that went into accounts to build this, and just take a look at things, discuss some vulnerabilities of the model, some limitations, how you would build this in a real world scenario, because this was created specifically for this particular class. And if you've not watched the live demo, it's just the video before this. We just did a quick demo of it. Right, we did a quick demo of the model, and then just talked about certain things about it. It's a very, very quick one to watch. So yeah, I enjoyed that. So yes, moving into it, we have building your first predictive model from scratch. So this is just to tell us that in the upcoming class, that's a paid class, this is a project that our participants, our students will be getting hands-on with. So the aim of this is to teach you to participate and to create this data science workflow such that you can then go out there, learn certain more things to it, add more to your repertoire, to your skills, and be able to recreate this for any AI model possible. So this is the basic data science workflow. This is what you need to understand. you can now pick each part to improve yourself on. So that is kind of what we are trying to achieve with the paid class, to teach you this hardcore part of it, to teach you the core foundations, the core strengths, right? Such that you can then go ahead and build up on it. So that's why I keep emphasizing that the paid class is not a become an AI developer in 6 weeks kind of thing, please. That's ridiculous. No one should be telling you that. You should not even believe that. That's practically impossible. But you can build a solid foundation, a strong foundation in 6 weeks, such that you already know so much. You already know what you're working on. You know you're not lost. You understand what you're doing. You understand where your strengths are. You understand where your weaknesses are. You understand where to work on. And then you are given the materials to work on these things in the paid class. So trust me, it's going to be a splendid time. It's going to be an exquisite time. You'll be working on the project yourself. Your data science workflow is yours. So from the problem to the solution, you create it all yourself under my guidance, and some other friends are just going to put together. So believe me, it's going to be a splendid one. So please, if not, please come and pay for the class. Like I said, if it's a problem of funding or something, this is something we could always talk on. So please just send me a DM, send me a message on WhatsApp, and then we can talk more about it. So yeah, I'm yapping a lot. See, I like to talk as a teacher. I like to talk. So this is going to build in your first predictive model from scratch. So this model predicts house prices in Ibadan. It's a moyin.dev learning project. In this process, we just walk through loading and exploring a custom housing data set. So first, we talk about the data, right? Let's start from the problem definition. So we'll be alternating between this and this, and then the live model. So first, problem definition, right? The problem definition here is that housing prices in Ibadan is erratic or are erratic. A common example would be an house a self-con that you expect would cost something like 350,000, which is a very fair price taking into account of everything. You could hear something as high as 550,000. What is adding to it? Fees like agent fee, caution fee, and so many padded ridiculous fees just to pad the price and make you pay so much more. And the price could even be so much cheaper that the agent that is collecting the money is not even it's not sending the full rent he says it collects to the landlord. It's just sending like maybe 200k to the landlord. So housing prices are erratic, right? It's just erratic. There's no unified regulation for it, and it's something that the Oyo State government should actually consider for a citizen as Ibadan. I know this is even much worse in the Lagos State, where you even have the environmental conditions, the housing conditions itself, and then you hear the ridiculous prices, and it's like for this same house. So housing prices being erratic, it's a major problem. It's a very big problem, and this model aims to create a unified regulation for that, both on the client side and on the agent side. So it's sort of a unified and a regulatory AI to predict the ideal housing price depending on certain features that you give it. So we're just going to it now. So we're building and training lead generation model using metrics like R2 and then mean absolute error, making new predictions, etc and etc. So next year we have data collection. So how did we go about the data collection? The data collection used here is a synthetic data set. So this was all the data set was generated by AI. So I just gave it arbitrary values. I gave it some values that were expected and ideal per location, and just told it to create and generate a data set for me based on this range of values. So yeah, it's a synthetic, it's a custom data set. If you would want to do this in real time, you would have to go into the market and then curate a much more comprehensive data set. Remember, the more the data, the more accurate the model is. So you have to create a comprehensive one. You have to partner with agents to give you the ideal price for a place, right? So it's more like you could get a proper someone that understands our housing how house has been priced. So it could be someone under a regulatory body that understands the ideal price for an house based on certain features, based on the environment and the likes. Would take all this into account, give you an accurate figure. So it computes this for a number of places, a number of areas, a lot different things. It's a very expansive project. A project I'll be happy to work on though. It's very expansive, very comprehensive, very tasking. So for the aim of this project, for the aim of this learning project, it was simplified and dumbed down. We made a lot of assumptions just to make sure that there were just about 3 or 4 features that will be taken into consideration here. So those 4 features were distance to the market, the number of rooms, the distance to university environment, right, and then the number of hours of light per day that the house is getting. So based on those 4 features, right, we created an AI model to regulate housing prices, to create like a unified structure for regulating housing prices. So yeah, that's about data collection, a synthetic data set. Then next we went into data cleaning. So yeah, let's just do data collection. So for data cleaning, remember, before you clean your data, you have to bring in your data into the tool which you'll be using to clean your data. And what's our tool? Pandas, a tool that has multiple actions. So Pandas is the tool to manipulate our data. So first, we have to load the data set. And the beautiful thing about data science, like I said, is very repetitive. The structure is the same. Some things change, but the structure is the same. The skeleton, the foundation is the same. So the first thing we're going to do is to import essential libraries: Pandas, NumPy, Matplotlib, sklearn is basically our library for our models. Yeah. So we load the data sets. CSV values are basically comma separated values, basically an Excel sheet, but instead of lines separating each value is a comma. That's the best way to put a CSV file. So we bring this in here. Then next we view the first 5 values. So that's just df.ed. So df sorry, let me just go back in and tell you what we're doing. So this is the part basically where the data, that's the data set, where it is on my system, right? So I brought that in and then I call this part, right? So now I'm telling this that Pandas, right, that's the tool, right? The tool Pandas is reading the CSV. So the tool as a function, remember, a function is an action. The tool as a function, the function is to read the CSV. So basically, you see, it's like English. Read this CSV, read these data sets. Where is the data set in this part? And that's all. So, and when you read it, store it inside this object here called df. Do we get? So, store it inside a variable called df. And that's just all that has happened here. So, df is basically a data set, but in form of pandas for it to work with. That's all. So, df.ed is basically saying, view the first 5, right? So you could put in any number here. You could put in 10 here, for example, and it will show you the first 10 values. Let me just show you here. You see, first 10 values. But when there is nothing there, it just shows the first 5 values, and that's df.ed. So like we see, let's look at the data set. It has location, it has distance in university environment, and the logic here was that the closer an house is to the university environment, the more expensive it's supposed to get. So these are like the logic that went into creating the synthetic housing data set. Like I said, there are more comprehensive complexities that affect an housing price, but in a bid to make everything simplistic, we made a lot of assumptions and we boiled it down to just 4 things. So we have distance to university environment, the amount of electricity is getting and house is getting depending on the area, the distance to the market, class if you want to buy foodstuffs, and then the number of rooms. Yeah. So we show the correlation and the relationship later on. Then basically df.info is give me an info about this data set. So you are saying an action, a function, give me an information about this data set, describe the data set for me. I are basically asking, are there any missing values? So what you have here, df is null.sum, is basically saying, are there any null values? So are there any nil than nil values, right? Remember, nil is different from 0. So are there any null values? If so, what is the sum of everything do we get? So it checks for the missing values and gives you a sum. So this gives an information, this gives a description of it, and then this tells us, you know what, there are no null values. So this is just basically saying our data is clean and we are ready to go. So next, we've done problem definition, we've done data collection, we've done data cleaning. We proceed into expression data analysis. Like I said, expression data analysis is basically you visually representing the graph to be able to see the relationships and the associations in between features. That's all. So we use matplotlib. Remember, we imported matplotlib as PLT. So PLT here is matplotlib2, the matplotlib2. And what does the matplotlib2 do? Is it plots features. It plots, it basically plots a graph. So we are saying that I want a scatter plot, right? Where I'm plotting the distance to university environment in kilometers versus the annual price in naira, so versus the rent. So this is basically to show the relationship between the distance to university and the annual rent price. We also do that for the number of rooms. How does the number of rooms relate to the annual rent price? Also doing that for the electricity hours. How does the electricity hours relate to the annual rent price? How does the distance to market relate to the annual rent price? How exactly does each location affect the annual rent price? Do you understand? So yeah, that's it. Now this is the view of it. So sorry, I was supposed to have zoomed in. I hope you all have been seen. So sorry about that. Yeah. So yes, this is perfect. This is much better now. This is much better. Yes, this is much better. So yeah, this is the first result. Comparing basically showing us the relationship between the distance to university environment and the annual rent. So we have the distance to university as from 1 to 7 kilometers, and the annual rent from 200,000 to 800,000 to, I think this is $1 million here. Yeah, that should be $1 million. So what we see is there's a trend, right? The further you get away from the university environment, the more the reduction in the annual rent price. This is just saying an ideal relationship is somewhere that is closer to the university would have an higher rent because they want to hike prices around the university environment, which is completely understandable because of the demand and all. So this is just saying that we expect that the closer you get to the university, the more the price would be, and that's why you have this trend. However, because the distance is not just the only thing that contributes, we have things like number of rooms. Based on the distance, the number of rooms differ, so the price will differ. But the general trend just shows us that the more you get closer to university, the more the rent you should expect to pay. Similar trend here too for number of rooms. The more the number of rooms, the more the rent you pay. That's straightforward. Similar thing for electricity hours. Yeah, you see, the more the electricity hours, the more the rent you pay. Then next, we have the market distance. This is the fun one because you might expect that the closer you are to a market, right, the more the rent should be, right? But what we see here is the most expensive rooms, right? The most expensive houses, most expensive house areas, they are not especially close to markets. In fact, they are some distance away from the market, but they are not they are not like excessively far away from the market. So the sweet spot is in the middle. That's the beautiful thing about data analysis. When you plot things out, you reveal things that you didn't even expect would be there. So this is a revelation here. Showing us that market distance affects, sure, because ideally you'd expect that, okay, the closer you get to the market, the more the rent will be. But premium neighborhoods that we see, they don't like to be so close to the market, and they don't like to be excessively far from the market. So they want to be in a kind of a middle situation, a middle ground situation where the noise from the market is not affecting them, but they are still finding it easy to just simply go to the market. So, and that is what here is 2.5 kilometers, and that's what we see. And then we do an average annual rent by area just to show you which which on average, which area has the most strength. And we see that UI campus has the most amount of rent. Then Abuwo and Samanda, very, very close. Barika, Bodija, similar to. The list is IITA. This probably took into account the fact that it's quite far from the university environment and also other things. Yeah. But yeah, this is something that it's very fun to play with, it's very fun to interact with. It's interesting to just learn and then view what goes on behind the scenes. So, as I was saying, what we then do now is to build the predictive model. In building the predictive model, right, you want to do feature engineering. So, like we said, we've done EDE, now we are at feature engineering. Feature engineering is where you select the features. So now, because we have a simple data set, we don't have to do much work in feature engineering. We've all selected the data. We've all selected the features here. 4 features: distance to uni, electricity hours, distance to market, and the number of rooms. On a normal day, there are some cases where it gets so complex that you have to combine 2 features together to give a feature. That's why it's feature engineering. It takes a lot of thinking, it takes a lot of analysis, it takes a lot of time just for you to create something better. You might have to combine 2 features. You might have to take into account different features to produce a single feature and then use that feature in accordance with other features to train a model. So it gets complex. It's why it's an engineering process. It's not just feature selection. You are engineering out the features. So this is the simplest you can have, where you just simply select the features that matter, which I have done here. So the features are X and then the target is Y. Like remember, Y is a function of X, right? So Y is equals to F of X. That's just what it is. So Y is the target, which is equals to F of X, where X can be anything like x raised to power 2 minus x raised to power y or something. So that's where you start getting into calculus and the likes, but we don't need that for here. All we just need to know is y is equals to f of x. So y is the function of x. So that's what y is the target, which is dependent on x. And if any of you is into statistics, think of it as dependent variables versus independent variables. So y is a dependent variable here that its value changes based on independent variables present within X. So we specify the features here, saying that these are the columns I want to be my features. So we tell, we are basically specifying the features here. So, okay, in my data set, these are the columns that are my features, and this is the column that is my target. And train test space is basically a function, right, that helps you to split your data sets that you have into 2. Right. So, why do you want to do this? You don't want to just dump all of your data into training, because then you don't have anything to evaluate how good your model is. So, the best thing to do is you have your data, you've collected your data, you clean it together, right? And then you now divide it into 2. So, there are different splits you could have. You could have 60-40, you could have 70-30, etc., depending on how much your data set is and other factors too. So what we are basically saying here is we want a test size of 0.3 with a random state of 42. Yeah, and we are basically splitting X, which is our features, and Y, which is our target, into X train, X test, Y train, Y test. So the target features, the training target features, the training features, the test features, the targets, the training targets, and the test targets. So yeah, that's that. Then next, we build the model. Like I mentioned, building the model is basically fitting the model, which is what we see here. We specify what model we want to use, which is the linear regression model, and then we say, you know what, model.fit. So fit this linear regression model using these training values and this using my X test and my Y test. So I'm saying train my model using my training features and my targets feature. Using my training features and my training targets rather. Sorry. So next, once we've trained using this, we fit the model. The model has been fit. Then we evaluate the model we've trained based on our X. So do you understand now? So you train, when we split the data into 2, we have the training set and we have the test set. So we train based on the test set, we train based on the training set rather, where you have the features and the target for the training set. You train based on those, then you predict using the test features, right? Which means you are going to be comparing it with the Y. You get with the we are going to be comparing it with the answers that we have to show you guys, which is the target for the test. So then we print the values, which is the coefficient and the intercept for the model. So these are basically values of the current model that we fit. So what coefficients are basically telling you is how exactly do they correlate. So remember we talked about the each of the features correlating with the average rent price. So something like distance to university environment, it correlates to the average, to the eventual rent price. So how much do they correlate? Is it positive or is it negative? That's what the coefficients tell us. And then the intercept is basically saying that if everything else is zero, that means the light is zero, distance is zero, number of rooms is zero, and so much more, what would be the price? And this is saying that, okay, if the number of rooms is zero, it's be 50 to 90, which is not really accurate, because you can't have a zero number of rooms. But it just tells you that there is an intercept here. And the beautiful thing about linear regression model is it functions on the mathematical function of y is equals to mx plus c, which is the equation of a slope. Because a linear regression model is basically a slope line. Do you get? So we're going to see it. So you remember in our drawing of if you are trying to get a slope, you plot certain data points, you find the line of best fit, and the equation of that line of best fit is y is equals to mx plus c. That's what a linear regression model does here. It plots certain data points, it tries to draw a line to find the line of best fit, and then it predicts based off of that. So this is just interpreting the coefficient, saying that there's a negative distance to university coefficient. Basically, as the house gets further in the university environments, the price decreases. So increase in distance, reduction in price, so that's negative. Positive electricity hours, the more the lights, the more the price. Positive distance to markets, like we saw, ideally the closer you get to the market, the more the average rent, the more the annual rent should be. However, it is not true for certain places, which is why it is a slight positive relationship, not a very intense positive relationship, because there are certain places that will just be outliers, because that's the sweet spot. Do you get? So strongly positive room coefficient, of course, basically saying that for every number of room that is added, annual rent should go up by about 100k, which is something I don't think we have also as a sort of templates to follow when agents price. So yeah. Moving on now. We've sorry about that. Moving on now, we've talked about feature engineering, model building, and model evaluation. That is just to monitor and deploy. So what we are going to do next is just to evaluate the model and just do a bit of testing. So for the evaluation, we're using two parameters: the R-square score, which measures the amount of variation captured by the model, variation of the data set captured by the model, and the mean absolute error, which basically is a measure of how far away is the answer the model predicts from the actual answer. So how far away it is, what's the error like, then that gives like a measure of the accuracy. So what we have is mean absolute error is 26,645, which means that for every annual rent price my model will predict, it will be off by plus or minus 26,645. And then the R square is basically 9.7, which means it captures like 7% of the variation of the data sets. So that's basically what we are saying here. That's what we are saying here. So for the MA, you would say it's pretty good, because 27,000 is relatively small compared to something like in the grand scheme of the rent prices. So it's pretty good, but it can be improved, it can be better. That's something I always tell people. It can be better. It can be better. So this is just a line that shows the visual but shows the actual. And remember, we have a line of best fit here, and we can see that there are predictions, right? It's very close to the line of best fit. So the line of best fit is the actual value The blue is the prediction. So this is telling me that it was quite close, but it wasn't it. But still, it's good enough that it's very, very close. And these are just metrics by which you can evaluate and then improve the model based off on, right? Especially for a regulatory council. Just make it very, very transparent, make it something they see. And then just to interactively test the model, I'm not going to be doing much because we have tested it before. So we go to somewhere like Agbo, for example. Agbo, Agbo has preset values based on the distance to university, the electricity, distance to market, and the number of rooms. So, as usual, the self-con based on the amount of rent, and based on the ideal environment for a student, and then we predict the rent. It comes out to 252,000, telling us that with these values, the ideal price for an house should be 252,000. And this, like I mentioned earlier, it has a lot of applications, it has a lot of impacts it can make. This is very, very solid regulatory tool that brings transparency to the government. It is something that corporates or corp members or anyone coming in to the University of Ibadan and they need a quick place to stay, they can always just look for something like this and stay there. And it's also good too for people like students too that are looking for houses, just to know your budgets in mind, and it gives a check to the agents because they cannot just overly hike their prices. Think of it like boats, where boats gives you an ideal price based on your journey. Something like that for housing prices is good, and it's actually a banger startup idea. Something I'd love to work on maybe sometime in the future. So yes, thank you very much for listening. That is the live demonstration. If you want to watch more of the live demo, like I said, there's a video on it under this one. You should see it under this. There's a video on this previously posted on my channel. And please, this is just showing us again the 6 weeks practical and the session camp for beginners and intermediates. So originally it was supposed to start December 1, but because some of the students learning will be taking their exams through December, we decided to push it forward. And then I think I'll drop the date after this. Just know the date where we're starting is anytime from December 20. We'll be starting this. So please be prepared. If you have it in mind to pay, right, don't be caught unprepared. Send me a text so I have it in mind that okay, you have it in mind to pay. I'll have you in mind, I'll send reminders or something. I'll send content maybe to give you a guide. And yes, for this boot camp, you do need your laptop. You need your laptop to work. Please, you need your laptop to work. So what we'll be doing, you'll be building your first fully functional AI model, which is basically what we've done just now. You take a problem of your choosing, you solve said problem of your choosing using linear regression model. So I'll walk you through this process. I'll walk you along the way. You will learn. That's one thing I keep saying. You will learn. So we have live Q&A sessions. So based on the classes, we'll just have like maybe an hour where we have question and answers. Let's say you work today, you have a bit of questions. Ask your mentors, you get answers. Direct mentorship throughout the 6 weeks. You have access to mentorship through the 6 weeks. Access, unfiltered access with whatever you need to be provided. Weekly mini projects to strengthen coding skills. So as you complete a module, maybe you learned about programming in Python, right? Just do a mini project, just something to build yourself on. And yeah, the final hands-on capstone project, which is your fully functional AI model, you get a certificate of completion and then access to created learning materials. And yes, because of the student environment we had to slash the price down from 50,000 to about 25,000, which is fair considering what we'll be teaching and also the fact that it's addressing the student population. So once again, please come for the class, pay for the class, scan the link to register. This is the account details here. Once you send the link, save the proof of payments and then scan to register and just or click the link below to register and upload your proof of payment, and as well I'll reach out to you and then add you to the class group. And once we are starting in full. So yeah, thank you all for listening. Thank you all for coming. It's been splendid teaching you. I these days I actually enjoy teaching. So it's been nice teaching. I wish I do I wish I have also an avenue more to interact with you people. So, because I personally love interactions when teaching, so I prefer physical mode of teaching to online. But we'll make do with whatever we can. I will make it as interactive as possible. So please and please, if you have comments, you have questions, go drop them in my, go drop them in my DM. You could drop them under this YouTube page. You're welcome to reach out to me anywhere, whether on LinkedIn, whichever mode you want to reach out. I'll be glad to answer any of your questions here. Once again, thank you very much. Have a good day. Bye bye. See you next time.